I don't know if that's recording. You guys, you can see this, right? So maybe just as a like a reminder of what we did, just so that you kind of like remember some of the words maybe. And then maybe what we can do is like, if there's stuff that you kind of don't remember, should we just jump in there? Do you know what I mean? So we took in episode 1, yeah, I'm talking about episodes. Episode 1, we talked about it's a pure language, it's strictly typed, and I think we would have felt some of the pain of like when it's strict. It's not just like sort of typed, it's freaking proper strictly typed. And we saw that like when we were trying to log a string and trying to get an effective unit out of it. It's like, no, the types have got to match up completely. Like the compiler is going to enforce types. There's no kind of like, oh, like casting things to different types and taking a bit of a chance. Like, no, the compiler, like functions have got to be explicit about what they take and what they return. Even things like, like the log thing, which logs a string and creates you an effective string. You can't just like carry on with that effective string. It's like, no, you have to pass it to a function that takes a something of string or whatever. So it's like when we say strictly typed here, we mean like like kind of the extreme of the word strict there. It's also implicitly typed though, so it means the compiler can infer a lot of the typing as you go along. So you don't have to be explicit about your types. Of course, while the compiler is compiling though, it is going to be very strict about the types that it does infer though. So like those two things, although maybe they're like related because they're around types, is they're kind of they're separate, implicitly or explicitly typed versus strictly or non-strictly typed, or dynamic maybe. I don't know. We talked about side effects, so like the language you can't just. So side effects are kind of are sort of dealt with in a special sort of way. It expects all functions to be pure, which means given one particular input, I always expect to get a particular output. To the point where it may not even run it if you don't need it. And that would be something called lazy. Actually, we talked about lazy versus not lazy. So PureScript is actually by default not lazy. What is that? What is it called to be not lazy? I don't know. Unlazy? I don't know. Whereas actually the language it's based on, Haskell, well, it's heavily inspired by Haskell, is actually by default lazy, interestingly. So PureScript diverges from Haskell a bit around this thing. So side effects, immutable data structures, of course, like all good languages should be have immutable data structures. So in fact, PureScript, like there's no alternative. Every data structure is immutable. Then in episode 2, we like defined a function. It was the basic stuff, which is like, hey, given an a or like a string and an int, I will give you back a string or something, and it's like getting used to that kind of syntax. We also played with these little jobbies, the pound and the dollar, which are like allow you. It's effectively the apply thing. So these are kind of like syntactic thingies. So if you've got a function f which takes an x, and it is if you take a function which takes a string and returns you a string, and it goes f of x equals like whatever, like to uppercase of x or something. I don't know what the implementation looks like. And you want to call f, I can call f by saying f of Tom. That's fine. But I could also go dollar there, and what that effectively does is it's the same as it's like the apply function. So it's like take whatever's on the right and give it to the thing on the left. It's like very weird in this context because like it's not required, but dollar often is a way of bracketing all the stuff on the right, if that makes sense, because it could be that you have some other function that gives you the tom. So like g of 5 gives you a string or something like that. So you could remove these brackets and you could put a dollar there, which would then resolve everything on the right, pass it to the thing on the left. Yeah, so that's what dollar does. Dollar, sorry, and pound is just really the opposite of that. So you could rewrite this thing to be like pound of f. Do you know what I mean? So if you know F sharp, pound is very much this operator, like the pipeline thingy, and dollar is the opposite pipeline. That one. I don't know if anyone knows F sharp, but in F# like lots of pipeline-y type stuff. In this language, of course, there's lots of pipeline-y type stuff as well, and it's dollar and hash to do that. There's this ability to create let syntax. So if you've got a so when you're writing a function, so f of x, and I want to do something with it, like whatever, like log stuff or whatever in my function, and stuff, like I want to start factoring out what is stuff, because it could be, oh, like we want to take stuff, we want to take x, and we maybe want to like append. So I'm showing you how to append strings with this thingy here. I want to append the word dog to those strings and then log it. But maybe you want to refactor that out because it's starting to become big. You can use let syntax. So you can say let and in, and I can say let x equals, maybe x is not a good idea. So you can say let y equals x with the thingy, and then I could log y. So using let syntax, I can sort of refactor and help reduce my amount of code. And of course, I can have many things here. A equals 5 and R equals hello world or something. So I can create like sort of like a whole lot of values. I was about to say variables, but there's no such thing as a variable. They're values, but like a whole lot of variables, up ahead, and then in my actual function code, it just like uses those variables or whatever. So that's let syntax. So keeping in mind, you need this because there's no there's no like statements inside this language. So I can't do two things. I can't like log y and then also log x. Like I can't have two lines. It's like f of x equals one freaking thing. It can't be two things. There's no open scope or anything like that. There are ways to achieve that sort of thing, but like every function is a single expression. And so you need this kind of thing in order to break that single expression down into like its composite parts. So that's let syntax. There's an alternate called where syntax, which is really just where you put the things at the bottom. So you can say log. So f of x equals log of y, where y equals that, right? So they're totally the same. And actually, I interchange them depending on how I feel, or what looks neater sometimes. Oh, cool! I just got load shedded, but I think I'm still online. Yeah, I have a UPS under my desk, which Minton gave me. You guys can still hear me? Yes?
Yeah, all good. Nothing changed.
Oh, that's amazing. Maybe I should turn my light off to save some battery. Is it load shedding, Alex? Anyway.
I don't think so, Tom. I don't know of load shedding.
It's just my crappy neighborhood. Yeah. It was pretty common. Okay, then in episode 3, we talked about record syntax. And we talked about how to pattern match stuff. So records are these things where you can create like a type. Geez, I'm going to remind myself actually. So I think I can go type user equals, and I can create these kind of like brackety structures. So I could say, hey, a user has got I think I'd do 2 jobbies, has a name, which is a string, and an age, which is an int. And like look at the syntax, you look at like how it's formatted. This is quite common, certainly in Elm, PureScript, Haskell, this sort of formatting. But anyway, what user is now, it's a record which has got 2 fields, age and name and age, which are of type string and int. And that's cool. So you obviously want these kind of things, this record type thing. Then we talked about pattern matching. In terms of function arguments. So what that means is, say I've got, yeah, okay, so we could do this like, yeah, okay, I've got an idea. So we could go f of x. Okay, so let's say f is a function that takes an int and returns a string, right? So if I go f of x, and like what I want is like I'm writing a weird function, but I could say, hey, f of 5 equals it's 5, right? Or f of 0 equals 0, and f of 10 equals dog, and then f of anything else, z equals like, I don't know, it's just, and then sort of like some way of converting that Z into a string, which would be like show. So it's like what I'm demonstrating here is like pattern matching on that first int. So it's like, oh, if f is 5, if the kind of parameter z is set to 5, then the answer is that. F of 0 is 0. Does that kind of make sense? This is pattern matching in terms of function arguments, and this could be a bit weird. Like in any other language, it would be like f of v equals, like if v equals 5, then I don't know, return it's 5, right? Else if v equals 0, then return 0, right? So it's actually just like a nicer way of writing an if statement. I'm just repeating the function name and the pattern matched argument, like, oh, if it's set to this value, then here's the answer, right? Does that kind of make sense? Happy, comfortable-ish with that, or no?
But Tom, there's a big part of it that I don't know if PureScript has, and that's the deconstruction, which I find very powerful.
Yeah, totally.
Like a tuple or something. I don't know if it's worth showing that.
Yeah, totally. So I mean, this is the start of pattern matching. You could also, if we had that earlier user structure, so we had a type user, sorry, capitals are important, so all types must start with a capital. So if, sorry, I should format it like this. So if a user had a name and an age, which was an int like that, you could, and say this function f took a user and returned a string like that. We can also deconstruct the thing that gets given to us here by saying, oh, it's a user, but I actually want to get out it's like name equals name or something. I suppose I could go, I think it goes this way. N equals name, I think like that.
Yeah, I also can't remember.
And then it's like name, something like that. So
age, more than 10, or I don't care about the age. It's very powerful for me deconstructing it like this.
Yeah. So pattern matching allows you to do this kind of thing. Pattern matching is a combination of two things: matching a thing and then setting a value to something inside it. So here you can see it's like destructuring this record, and it's looking inside it for a name field, and then it's setting it to, I don't know which way around this is. I think I've totally buggered this, but it's like then it's setting it to a value which is available in the scope of this equals. Do you know what I mean? Anyway, like records are quite tricky, and the syntax, you can stumble a little bit over the syntax. I don't want to get caught up on it. Then in episode 4, we talked about more pattern matching, which is great, and then an intro to ADTs. So these are algebraic. So ADTs are not the security company. It's algebraic data types, also known as tagged unions, also known as discriminated unions, something like that. I think it's got a few different names. Oh yeah, also known as product or sum types. Stuff like that. So they've got different kind of names, but algebraic data types is a sort of like their name. So what are ADTs? ADTs are like very simple. They're just like this thing data. So you use the keyword data. Earlier we used the word type. Type is like an alias. So I'm saying, hey, I've got this record. This record itself, like when I define so like I could say type age equals int. So what I'm saying is I'm sort of saying there's an alias to int called age. Do you know what I mean? So here I can now have a function which takes an age and returns a string, which is like really cool that I've just created a brand new type called age. But I've kind of made it interchangeable with int. I've said that these things are like quasi the same. You know what I mean? Age is the same as an int. And so earlier when I created that record and I had like name and age, etc., not in the syntax. I've kind of like, and I called that user. I said, oh, your user is like an alias for this kind of structure, because I couldn't continue to pass that kind of structure around as well. You could actually have a function which kind of does that. So its type is like this unnamed record thing. Do you know what I mean? But like obviously it makes more sense to give it a name, right? So the keyword type is a way of like aliasing things together. You're saying, oh, this is equivalent to this other thing. So it doesn't really create new structure in the world. It just gives new names to existing structures, right? Whereas the keyword data is saying, hey, I'm creating a whole new type. And I can say like user, let's go with that same thing. I can say user is like, and here it's very powerful. What I can do is I could say, hey, it's like an anonymous user or something, or he's a logged in user. And what I've used there, like here you can see that this is like a sum type, it's an or. So it's like a user can be either an anonymous user or a logged in user or a, I don't know, admin user or something. And so I've created a new type called user, and he's got 3 different constructors, is what you would call these things. This looks a lot like an enum or something in another language, except that I can also pass parameters to each one of these constructors. So I could say, hey, he's a logged in user with a string. So like when he's logged in, he's got a name or something, and that's his string, or like a string and a date. I don't know. So when he logs in, we've got to give him his name and the date that he logged in or something. If he's an anonymous user, maybe he has nothing. I don't know. Or maybe he just has a date. I don't know. If he's an admin user, maybe he has a list of permissions and a string and a date. I don't know. So with this type user, although it's one type, it's like a union of these 3 constructors effectively. Yeah. And the cool thing is, so here we can start to see that this is an OR type of structure. Of course, this thing here on the right is just a type. So a type could be a record again, so it could be an anonymous user with a name, which is a string, you know what I mean? So it's like the rabbit hole goes deep. You can then start to describe lots of detailed structures because these are just types. So permissions here could be a type. It also could be another data. It's like whatever. So does that kind of make sense? So these are what algebraic data types are. And what Chant mentioned earlier is that I can, of course, pattern match on these things. So if I've got a function and I want to like, I don't know, print the user or something, some stupid function. It may take a user and give us back some sort of string. When I'm defining this function, I can go print the user, and it's like, oh, okay, I don't want to go like a little, I could do it like this. I could say, oh, print the user, it's a user, and then I sort of like want some sort of derived if thing. So the way I would do an if is I'd go case user of, so it's a case match. And now I could say, oh, if he's an anonymous user, let's just give that a string again to keep it simple. If he's an anonymous user with a name, then do whatever, do stuff. Or if he's a logged in user with a name and a login date, because now check, I'm matching the name from there and the login date from there. And in fact, the compiler will 100% check this. You cannot leave these out, and you couldn't introduce a name where no name exists or whatever. So like that's one approach, is I could use this kind of case statement type thing. And of course, this is going to have many lines because I've got an admin user with like a blah 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 stuff, etc. The other way of pattern matching this would be print user anonymous user name equals dot dot dot, and do this kind of 3 times, one with a, that kind of makes sense. So it's like I don't really need to use the case statement here because I could just write the function sort of 3 times with the 3 alternatives. Does that make sense? So no matter how I print user, so if I go print user, Tom, when I'm invoking it down, or if I'm calling that function, it will call this one. If Tom is an anonymous user, it'll call that one. If he's a logged in user, call that one if he's an admin user. And it introduces these 3 variables. These now become, I hate the word variables because they're not variable, they're values. It introduces these 3 values into the scope of the expression, right? So it means like, oh, okay, so if I want to print the user of the admin user, and we know he's got some permissions and string and a date, maybe all I want to do is print his name. It would be B. If it's this guy here, I want to print his name, it's name, and in that one there, it's name, right? So it's like there's the 3 alternatives. Yeah, happy with that. So that's These are algebraic data types. Any questions about algebraic data types? Completely simple, right? Hey, Kieran. Hanno. Welcome to the deep end.
Hello.
Is this the deep end? I think Hanno is comfortable with this stuff. Am I right, Hanno?
Yeah. I have a question.
Mhm.
Is there a reason we would, like, I don't quite understand the syntax of writing out the function 3 times. I understand that it's pattern matching and you're defining a function for a certain case in the algebraic data types, but it
Yeah.
feels like a lot more typing.
A lot more words being typed.
Yeah. Like, is there a scenario where that's shorter or better or clearer somehow?
So you don't like the fact that I have to write the function name more than once?
Yeah, I guess I'm just more used to the case syntax.
Yeah. So like, yeah, I mean, it's totally up to you. You can use either of these. It's not a big deal. You know, it doesn't matter. They compile to the same thing. It's just, I mean, yeah, I agree with you. Like if your function is like print user, you know, blah, 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 then it's like, yeah, I've got to cut and paste that blah, blah, blah all over the place. Whereas up here, I don't have to cut and paste it. All my overhead is this one extra line, line 40. So like this is 3 lines of code. That is a minimum of 5 lines of code. It's up to you. It's like a trade-off. I don't know. You can do either. It's not really a problem. Yeah.
Cool.
I mean, they compile to the same thing. So it's up to you. I mean, quite often I think it's like where this I think becomes this syntax is more interesting. I think it's when you're like doing a bit of recursion, right? So, and you're saying, oh, f of an empty list, like f of nil equals, you know, like say maybe I'm collecting an accumulator, right? Like you would know this sort of thing. So it's like I'm getting, so maybe f, let's just do it properly. List is a list of string, and at the end I want to return a string, right? Like maybe it's a concat. I want to concat all the things inside my lists of strings together, and at the end return me a string, right? And I mean, I'm not writing this properly, but like one approach might be like, oh, I probably want to keep an accumulator, right, as I'm iterating through this thing. So it's like, okay, so f takes my list of string, and so like a clever way would be to say, well, what's the head of that list, and give me the tail, and then I've got an accumulator, right? And I might say, oh, okay, so the result of this thing is like x appended to the accumulator. Maybe I want to put a space between them or something, right? So that totally makes sense. And maybe my end case is where I've got like nil, and the accumulator is just the accumulator. You know what I mean? Like in my mind, that maybe it looks a bit more scary, but I think for someone like you, that works okay versus going f of like, I don't know, the list, an accumulator, and then going case ls of the x, and then the xs, and then it's, oh, sorry, what I've forgotten here is I've forgotten to actually invoke f again here, as you can see recursively. But I think this is kind of the point, right? Like sometimes that terminal case in a recursion thingy, it looks nicer because you can just kind of ignore it, put it up at the top and go, okay, that's the terminal, and here's every other scenario. Here's the recursive case. Do you know what I mean? And for me, I think that reads a bit nicer than a big case switchy thing here. Does that make sense? Am I explaining that or no? Yeah.
Yeah, no, that makes sense.
But it's up to you. It's like 100% up to you. There might be some convention, but I think it's very much a personal thing. Any other questions about ADTs or these funny things?
Yes, I got one. Apologies, this
Yes.
is a dumb question because it's literally the first PureScript I've ever seen. But how is pattern matching different to just regular function overloading?
So it's a good question. I would say it's different. So function overloading can sometimes happen at runtime. Am I right? So overloading, I know overloading in C terms, does it happen at runtime? I think it does. Yeah, because it's got vtables, doesn't it? So it does virtual table lookups, and it executes at runtime. Pattern matching is very much compile time. So the compiler checks that every single case is dealt with. So it's completely exhaustive. You have to have, if you don't deal with every case here, so for example, if I'd left that out, well, yeah, if I left that out, that would be a compile error. It would say, oh, you're not dealing with the admin user case. It's saying you can't do this. Or you'd have to put in some kind of like, otherwise scenario with like an underscore. It's like, oh, everything else, like everything else. So the compiler would check for it being exhaustive. The other cool thing is pattern matching is a little bit more powerful than overloading because it destructures at the same time. So it's doing two things. First of all, it's matching that it's the right type, but then also what it's doing is it destructures the internals of that type into values for you, which is pretty cool. Whereas overloading, I don't know actually, Kieran. I would say like interchangeably. Like it's like vaguely the same thing. Yes, vaguely the same thing. Yeah.
Cool. Thanks.
Yeah. Interestingly, though, these are not just you. When you define these three functions, you can't like disperse them all over the place and have like other stuff in here. If another f of a equals 5, like this would be a compile error. The compiler wants you to put all three of these together because it really is going to compile this into really a case match type of thing. So it's syntactic sugar. There's no runtime overloading happening, not at all. It's all compile time stuff. So I think that's the major difference, but I could be wrong about overloading. Like overloading is such an old concept actually. Like it was dropped in a lot of like modern languages. So my overloading is like, I'm thinking about C, but I think that's I don't know. Anyway, something like that. Yeah, and apologies if this is your first one. We are diving head first, but there are already 7 episodes on YouTube where 1 hour each, unfortunately, where we go from like beginner baby steps. And so now this is 3 months later after our last episode, which was end of November. And so it's just a quick refresher. But if you're keen to, I'm very happy. Like I'm also happy to like run a second thing and dive back into the beginner stuff, or you're welcome to go and like rewatch those videos as well. I don't know, it's up to you, whatever you are happy with, or like try and catch up, if you like. I think it's a super cool language, Kieran, and I think you would dig it actually a lot. And if this is your first like foray into pure functional, I think like PureScript is like I've enjoyed it a lot. It's probably easier to get into than Haskell, but I think it would take you towards Haskell quite quickly. Like from PureScript to Haskell is actually a very small little bridge. And you may not even notice it. So like a lot of the stuff we're writing actually is Haskell. Oh yeah, then we talked about, so in episode 5, we talked about type classes. Now, who would like to tell me what type classes are? I owe Bhavesh, I think, a KitKat already. So this is for another KitKat. Even if you're wrong, you get a KitKat. How's that? What are type classes, guys? Is nobody brave enough? No? Really? Must I call out someone? Drickus, what is a type class?
No, I don't know. That's why I was silent.
I got you. Miguel, do you remember what is a type class?
I don't. I've actually been going through the code that we had done before. Like I kept it in like different files with names and I can't find them to try to refresh my memory.
Matt knows what a type class is.
I honestly don't remember.
Okay. Type classes are actually
for me,
very
I'm
simple.
struggling to remember the difference between an ADT, a record, and a type class. They're like blended in my mind and I can't differentiate them.
Yes, fine.
Yeah,
fine
mine
fine,
is
fine.
the record and the type class. I think that's why I'm confusing them.
Okay. Yeah, very different. So records are like data structures, right? Like ADTs. ADTs are data structures. It's like, oh, I've got like think of an ADT like an enum, but you will find once you understand an ADT, you start to go, oh wow, everything's an ADT. Actually, it's like like you can define everything in terms of ADTs. Interestingly, and then records are like exactly what they are. It's like a collection of like different disparate types. Think of like a JSON record. A record is just like it's like a table, in a database or whatever. Yes, go.
Can I
Meg.
try to take a guess just based on the one of the functions I don't think we've covered yet that I'm going through?
Yes.
Is this the ones where you can like extend the equals and show operations?
Legendary. You got yourself that Kit Kat, man. That's exactly what it is.
Those
And
are
look, it
type
even
classes.
says it here.
Okay.
Show and eq. So it's like type classes are actually like polymorphism. This is the polymorphism thing in this language. So type class is where I go like where I want to say like, hey, A, which is like let's just be like dumb. We've got A is an int, we know this, A equals 5, and B is an int, and B equals 10. And where I go A equals B, I've used this operator called equals here, right? And this is not built into the language. Like the language doesn't have the foggiest clue what equals is. This is like a library thing. So everything in this language, like the basic language provides you with close to nothing. And that's what's so beautiful is you can literally dig down to almost like how does the language compare to integers to itself? Like this is not like in most languages you would go, well, at C#, like I don't know. That just happens, right? I can't dig into the code of where equals are checked. You know what I mean? With PureScript you can, because at some point it bridges back over to JavaScript. Because like if you think about the machine code, like PureScript compiles to JavaScript, so it considers JavaScript to be its machine code, right? So at some point, it's going to compile down and invoke the equals inside JavaScript to compare things. But that's you can actually see the PureScript language get to that point where it like does the machine code foreign interface for equals. Anyway, what equals here is, and this may be like a little bit off the mark here because this is like ints and it's not quite like this, but effectively what type classes allow you to do is to say, oh, within the context of this thing, of this expression, a equals b, a equals b, which equals function should I call here? And it's like, oh, I should call the one attached to int. That's what type class does. So effectively int, and like int's a bad idea here. So like, let's do the user one, right? So we go data user, and we say equal. So let's say we've got two different types of users. We've got an anonymous, or we've got a registered, right? Registered. So we've got two kinds of users, right? And we go, anonymous guys don't have a name, and registered users do have a name. Brilliant. Okay, there's our type user, and we say, hey, like A is a user, and A equals anonymous, and B is a user, and B equals registered Kieran. Sorry, oh, I can't type your name, Kieran. There we go. So here we've created two users, A and B. We know they're the same type. They're of type user, right? But they're not the same, right? Because like the one is a registered and one is an anonymous. But we wanted to create a function to say like, oh yeah, we want to go like A equals B, right? We can say X equals is the same equals, let's do it like that, A equals B. So we're going to know that is the same is, check, I'm being like totally obvious here, but is the same is a Boolean, which is going to check if A equals B. Now the compiler, do you think we should do this in real code, or yeah, let's do this in real code. Oh, look what we were doing, guys. Yes, we were doing some scary cuck here, big time. Let's just do this. We probably want to keep that effect type stuff. Yeah, we can actually, oh yeah, this is an issue. Look, I hate languages that enforce spaces. And PureScript does, unfortunately, so that sucks. Anyway, there. I'm just going to go log hello or something. Hopefully this compiles. Oh, registered can't have a name. It's a string. Does this compile? Log of hello. Oh, effect of unit. A equals B. Perfect. Look, we've got our compile issue. So it's like, what this is saying is the same. So my compiler is saying there's no type class instance for data.eq.eq user. So it's saying, hey, it doesn't know how to compare users. That's what, so like in a roundabout, it's actually a very good error. It's literally saying to you, hey, I couldn't, if you know what a type class is and what an instance of a type class is, it's saying I can't find the instance of the EQ user type class. So basically it's saying, I don't know how to compare these two things. Does that kind of make sense? And like, yeah, you shouldn't, you don't know how to compare these two things because like that's a bit of a business logic thing. Like it could be that, so even if we had, let's create a C is also a user and C is also a registered Kiran, we don't know B equals C. It's like the compiler saying, I don't know, dude. Like, even though I could have probably worked out that they're both registered Kirans, it's like I can't do that for you. There's no way of checking these things. And remember, there's no, in this language, there's no like checking of like pointers and shit like that. It doesn't exist. There's no like, there's sort of like a hash code type check. Oh, these things point to the same memory, therefore they're the same bullshit. Nothing. You have to create that semantic, right? So the way we may do that is we'd implement a type class. We'd implement an instance of the EQ type class for our type user. Does that make sense? So let's just do it quickly. I actually don't have a clue how. Let's see if we can find an example. Data.list. Would list have a type class? No. Let's just look for EQ. Yeah. This is smarter. Let's just find the EQ type class. So for the non-pure scripters here, there's something called pursuit.purescript.org, which is like the ultimate reference for this language. So you can search for packages and stuff, but you can even do signature level search. So you can say, hey, find me a function which goes from an int to a string and gives me a string. You can query for that. And it says, oh, there's a function called drop that takes an int and a string and gives you a string. How cool is that, right?
Super cool.
So you can do signature level searching. So you could even leave out parameters. You could say, oh, give me a function that takes an A and then an int and then gives me like a list of int or something. Probably nothing. Oh, actually it's saying, oh yeah, no, there's a monadic version of that because as long as it's a monoid, that M works, the int works, and it'll give you back a monad of, anyway, you can do this kind of like very detailed searching. Anyway, so I'm looking, so pursuit is your friend. In Haskell, there's something called hackage, I think, which is the equivalent. So let's have a look at the EQ type class. There it is. Here's some instances. So let's just go and look. I mean, I always generally click on source there. Okay, so here's the syntax of how you create an instance of that type class. I'm going to go instance EQ user. You have to give it a name. In Haskell, you don't. And I'm going to go EQ of user, so user being my type. So I'm creating an instance of the EQ type class specialized on my type user, where. And what you have to do is you have to implement a function, EQ, given like the thing on the A, the left, which I call it, X, and the thing on the right, Y. I now have to implement the code here. Does that make sense? So I suppose I could go like, okay, so now like, here's where it actually gets quite interesting. And back to like Hanno's point here. So I go like, okay, so how do I compare these two things, right? So if I go case of X of, so oopsie, why did I do that? So if the X side is anonymous, and then it's like, well, case the Y side of anonymous, then that's true, right? Then so anonymous equals anonymous. Is that always true? I don't know. Maybe that's not always true, actually. I don't know, but I'm saying it's true here, right? If it's, and then I'd have to like be explicit about the case here. It's like, ugh, okay, this is going to turn into a nightmare because there's like 4 combinations, right? So let's just do it like this, where I'd go X of, so where it's anonymous and anonymous, here's our definition, it's true, right? Where it's a registered and of A and a registered of B and A equals B, then they're the same. Otherwise, it's like they're not the same, right? So we're saying as long as it's if they're both registered, A and B. So if B is a registered user and C is a registered user, it would be this one. As long as the name inside A and B are the same, then they're the same. If it's any other situation, that's false, because that would be like if it's anonymous and registered, or registered and anonymous, anonymous and anonymous. We're saying that's true. I don't know. Something like that. Anyway, what is this? Name A was shadowed. Why? Oh, yeah. Yeah, okay. So I should go A prime or something. A prime. You can use this cool prime character for shadowy type purposes. So now look, my compile error has gone away because it's saying, oh, cool. So now I can use equals equals here on things of type user, because the compiler has looked up and it's found the instance and matches them together. Does that make sense? So that's kind of like polymorphism. Yeah.
How would I extend that to compare user to just a string?
Good question. So that would be, so that wouldn't be the EQ type class, because EQ is always EQ of A. Yeah, it's always comparing an A to an A. You know what I mean? So it's two of the same types. It's the way of testing them. If you wanted to do that, I would say that's a function, right? So it's like is user, and then it's like, I don't know, the user and his name or whatever. You know what I mean? And you would go registered, and then like, let's go name prime and name, and then you would go name equals equals name prime or something. I don't know, but like I would say that's a function like that. You know, if I mean, maybe there is a type class out there for you, or you can write your own type class. I mean, you can write your own type class. Look, class of EQA where. So like, well, yeah, let's actually write our own. That's maybe the answer. So class, what do we call this? EQ name, maybe. EQ name of a where. Actually, this would be like EQ name of user where. So it's like anything compared to a string, or just a user compared to a string. If it's just a user compared to a string, I think it's just a function. If it was like anything compared to a string, that would be like EQ name. I don't know.
I'm sorry I got you down this tangent because I now have to go to my stand-up. But thank you
Yes,
very much.
you bastard. I'm leaving your tangent. Goodbye.
Oh.
Okay, so those are type classes. And there's a bunch of type classes. There's a bunch. Like there's literally hundreds of them. So if we go and have a look at, I think like where could we find some good type classes, like instances of type class? Oh yeah, actually if we look at, so let's find a type. Actually, why do we not have, yeah, these are the primitives. Anyway, like another one might be odd. Odd is another interesting one. So odd is like around ordering. Yeah, around a total order. So this is a bit mathematical, but this is, in terms of type classes, they can also derive from each other. So you can see here that odd is a type class which inherits from EQ. So that almost implies it's saying it's a further specialization of EQ. So it means that odd as a type class needs to also have EQ provided to it, because it obviously uses equals equals, you know what I mean, in its implementation. But so here for odd, you can see instead of you writing an EQ function like that one, you have to implement a compare function given the two elements of your things, and it must return an ordering. And it's like, well, what is an ordering? An ordering is of three types, three constructors of one type. It's either less than, greater than, or equals to. So what you can see already with ordering, it's for things like ordered lists or whatever like that. It's like it's a type which has some ability to be ordered. So that's very useful for other things. Whereas EQ is only useful to check two things. Ordering is like useful if you wanted a list of these users and you wanted to sort them by name or something. You could implement the compare function. And then sort that list by their names or something. That kind of makes sense. So let's go back to this thing because we were like, let's at least finish this. Intro to type classes. we talked about show. Oh yeah, show is another very useful type class. Actually, it is worth looking at that one. There's a type class called show. And what show does is it turns anything into a string. So it's very useful. So like if you want to print a user, you just have to implement or create an instance of the show type class for your data type and implement the show function that will then allow you to convert your object into a string, which is useful for like printing it or logging it or serializing it or whatever you want to do. Mostly show is really for debugging and printing type of stuff. There's another type class called read, I think. Is it called read or write? Can't remember. Maybe I'm wrong. I thought it was. Anyway, there are other type classes to like serialize and deserialize. You know, if you've got a data type like an ADT and you want to like implement a way of serializing that to a JSON structure or something, you would implement a type class to do that. Of type write, or maybe it's reader and writer. I can't remember. Writer. So this is like the monadic version. Anyway, that's what you can do with type classes. Okay, in the next episode, we talked about functional composition, so like composing functions together. So if I've got a function that takes a string and gives me an int, and I've got a function that takes an int and gives me a double, I can compose those two functions together, giving me a new function that, given a string, will give me a double, right? It like makes sense. You can like join functions together as long as their type arguments line up. You know what I mean? You can compose, and the composition. I'm going to kill this stuff. Looks like has this arrow. I think it's just a double arrow. I actually can't remember. Is it 3 arrows? Semi-group void. Yeah, was it 2 arrows? It could be that one.
I think it's 3, Tom.
3 arrows. Yeah. 3 arrows to compose something. So it's like if I've got x takes an int. What should we do? Takes a string, gives me an int, and then I've got a y, which takes an int and gives me a float. I don't know if float's an actual type, who cares? I can create a new function called f, which is like x compose with y. I think that's the right way around. I always get this backwards. Or I could also write it as y compose with x, like the back arrow type of thing. And then what f would be is a type giving from a string. So the string of the x, it's kind of effectively dropping that int because like it collapses those two ints together and gives me a float. Does that make sense? So that's functional composition, and it's like obvious, right? It maybe doesn't look obvious, but it is obvious. It's like, yeah, of course, this function composes with that function because the return type of this thing is an int, and this thing's first parameter is an int. So it's like I can join these two functions together, giving me a new function which goes from a string to a float. Of course I can do that. So composition. There we go. We talked about effects. Yes. I think we talked about it even more. And I think probably in our next thing we should dive back into effects. We talked about void and unit. Like this is very useful actually. Void and unit are worth understanding because this is a confusion I think from other languages. So you've got these two types, void and unit. Does anyone remember the difference between these things or what they are? Can anyone explain the controversy between void and unit?
Wasn't the void like the literal representation of like nothing? So this you actually aren't passing anything back, where unit is a like empty type. It's still a type, but it's just got nothing in it or no properties. I might be slightly off there.
No, close. Yeah. So I think you're on the right track. So it's actually very interesting, and it's like languages have gotten this wrong until the mathematicians came along and put them straight. So actually, you should think about void and unit in terms of sets. So you know what a set is, right? A set is like a thing which has elements inside it, right? Like the mathematical set. So maybe my definition of set is like if I had the set of all ints, I would say like, oh, int and this is not code, but like maybe I use this round bracket and I say, oh, so int is of type, these are its elements, 0, 1, 2, 3, onwards. Like those are the elements of type int, right? I may have the element, and if you think about it, int is like, well, certainly in a 32-bit language, like int is a bounded set. So it does actually it is bounded. So it means we know all the elements. It might take you a very long time to collect all of them, but like we know that there's a certain number of elements to it. It's like whatever, how many you can store in 32 bits. For the element, for the set of strings, it starts with maybe like an empty string, and then it's like the string with 1 in it, and then it's the string with 2 in it, it's the string with 3 in it, and it goes all the way up to like the string of, the string with Tom and the string with 1 and 2, etc. And you would say that the set of all elements of the set of all elements of string is an unbounded set because it's like infinitely large. You can always continue to come up with new elements of the type set, right? As opposed to int. So int is a bounded set, and the set of all strings is actually an unbounded. This is just giving you some cool words that you must throw around. So if you think of void and int in the same terms, voids is actually, it's the set of no elements. There are no elements in the type void. In unit, there's one element, and his name is the same as the set name. His name is unit. So that's the set name, unit, capital U, and the element is called unit also. But unfortunately, the guy void, he has no elements. So if you think, and it's like you go, okay, so it's not useful, but it is very useful because when you create a function saying, oh, I've got a function that goes from a string to a unit, effectively what I'm saying is no matter what you call, when you call f, no matter what string you pass me, I'm always going to give you back this element, unit. There's only one possible outcome of this function. It's the unit element. You know what I mean? It's like, so f given anything must give you unit. Like it doesn't matter, right? It doesn't matter what you give me here. So it's like, it's a bit wacky. Whereas, but it's still very useful because like maybe your function is like a log type function, right? And it logs a string. It wouldn't be able to give you back a unit directly. It may give you back an effective unit, but that's still useful. Still tells you a lot, that it may log that thing. You know what I mean? And then give you back the unit. Do you know what I mean? So it's still useful. So unit is still pretty useful. It's almost telling you it doesn't matter what you give me, I'm going to like throw it away. I'm throwing that information away. Give me anything you like, I'll throw it away because I'm always giving you back unit. Void is very different. Void is an uncallable function actually. So it's something that can't be done. So it's like if I go f takes a string and gives you back a void, it's like, okay, let's see you write that function. So f given anything gives me like what? I can't give you back an element of type void. So it's actually an unwritable function. It's a function cannot be written. Do you know what I mean? Nobody has got a void. It doesn't exist. So you can't write a function that returns a void. It's like, okay, got it. Does that make sense?
Yeah.
So void
So
is like
when
not the
when
same
would
as
you use it?
yes. When would you use it? Yeah. You would use it to describe impossible cases. That's when you would use it. So you would use it when it's like, oh, this is an absurd case. Like it's not possible to do this. Then it's like, oh, that's void. It's like it's impossible. So like the exact, I'd have to scratch my head as to why that's like a real thing. But when you would want to do that, but that's what it's for. It's like to tell the compiler this is not possible. This is an impossible situation, and the compiler will say, cool. Like if you manage to get yourself in that situation, the compiler is going to go, oh yeah, but you like this, what are you going to put here? You're going to put in a 5, or like what are you going to put here? You can't construct a void, so this will never type check. So it's impossible. The common way of implementing this is to like recursively call yourself. Well, it's like, oh well, it's the answer is f like of that thing, and it's like, oh, if you want to get this void, like call me with a string and I'll give you that void. And it's like, well, it will never get there. Do you know what I mean? Like maybe that's the way of returning a void, is to like call the thing that you're trying, it'll like never end. So it's a never ending thing. So anyway, it's void is not that useful. Unit is much more useful. Unit is the absence of, is like the throwing away of the input effectively. But most languages unfortunately call that scenario, they call it void, when actually it's really wrong. It should be of unit. And you see this in modern languages, like Scala's got unit, and I think F# calls it unit. Unit is correct, because like a function must always return an element of the set of things that it returns. Void is not, that's not possible. So void is, I think there's a function called absurd. Let's see. Yeah. So absurd is a function. Hey, give me a void and I'll give you back anything, right? How cool is that? This is such a cool function. So it's like, yeah, it's like a terminal, it's an impossible, uncallable function, absurd. So how does, this is just interesting now. Now we're in the trivia part of the end. Let's look at how they've implemented absurd. So given a void, I'll give you back anything, because you can do that. Because you can't give me a void. So it's like a promise that like I'll never have to fulfill. What do? They go, oh, spin A. I don't know what spin is. Where spin of void B equals spin of B. I don't know. Spin. It feels to me like it just gets stuck. Like if you do manage to call this thing, it will just hang. But you can't call it. The compiler will ensure it, because it's like you can't give me an element of void. So it's an uncallable. So what do they say? Eliminator for the void type, useful for stating that some code branch is impossible because you've acquired a value of type void, which you can't. Yeah. So it's like a way of saying it's an impossible scenario. It must never happen. And so you could do this sort of thing. In some cases, you may want to describe a structure where it's like I've got an either, and it's like of type void or int, and it's like it's because we're saying it's not possible that it could ever be this left side of the either. So it's like it's a void. No one can ever use that side of it. You know what I mean? Anyway, that's us. Caught up. Are we caught up?
Cool. Thanks, Tom. Yeah, everyone's running away from you now.
Awesome. Cheers, guys.
Cheers,
Speak
man.
to you later. Ciao.
Cheers, guys.